Welcome to the Process Model training series. In this video, we're going to tackle one of the most critical concepts in simulation, variability. We will cover three things. 1. Why representing variability is essential for success. 2. How to quickly turn raw data into useful distributions. And 3. How to understand the effects of that variability in your final results. First, what do I mean by variability? Let's use an example. If I recorded how long it took to process a task, I could simply calculate the average. But an average is just a single number. It doesn't tell the whole story. A histogram gives us a better picture. It shows the probability of different times occurring, but using a raw histogram in a model is clumsy and difficult to set up. A better solution is a distribution. This is a formula that approximates the probability of getting a specific value. Distributions represent real life. They capture things like how long a repair takes, a person's weight, or how many people arrive on a bus. Why does this matter? Because linking variable activities creates compounding effects. Imagine a simple system. People arrive and a server processes them. If we plan this using just averages, and the server average time is faster than the average arrival rate, we would conclude, great, no lines will form. But let's look at the reality using distributions. Arrivals vary. Sometimes a whole busload comes at once. And processing varies. Some people have complex issues that take longer. When we simulate this with variability, we see a totally different picture. Instead of 0 wait time, people might wait 30 minutes. Instead of one person in line, we might see 70. We didn't cherry pick a worst-case scenario. This is just math. Anytime you have two or more variable components next to each other, the compounding delays create bottlenecks you can't see with averages. Representing variability is the only way to see the actual behavior of your system. This might sound intimidating, but don't worry, we have a tool for this. From the Tools menu, select StatFit. This is a powerful analysis tool that converts your raw data into over 25 different distributions. Here is how it works. First, scrub your data to remove errors. Then, copy and paste that data into the StatFit entry form. Select the Auto Fit button, review the assumptions, and if everything checks out, click OK. The distribution at the top of the list is your best fit. The blue bars are your data. The red line is the distribution. Once you have a fit, select the Export button. This copies the logic to your clipboard. Go back to ProcessModel and simply paste it into the action logic or time field. Now, every entity passing through that activity will use that probability distribution. What if the data doesn't fit? Usually, this happens because the data isn't natural. For example, hospitals often discharge patients artificially between 1 p.m. and 6 p.m. due to administrative procedures, not because the patient has just gotten better. That is an artificial constraint, not a natural duration. In this case, two distributions are used. The first shows how many days the patient stays. The second distribution explains the discharge time. Another common issue is combining two different datasets. For example, a credit card supplier in the US produces between 175,000 and 350,000 cards on Tuesday through Friday. On Monday, they reproduce cards reported as lost or stolen. The Monday numbers range from 50 to 175. You can't combine those numbers. StatFit won't find a pattern. You must separate Monday's data from the rest of the week. Then, you will get two beautiful, accurate distributions. Now, let's try it. Open the model titled Why Variability and follow the instructions on the layout. You will run the model to record average times, then use the provided Excel file to import real data into StatFit. If you get stuck, feel free to replay the previous section of this video. Pause the video until you have completed the practice exercise. Welcome back. You may have noticed that running the model once gave you a specific result, but that is just a snapshot of a single shift. Think of it like basketball. If you watched a superstar player have one bad game where they scored 0 points, you might think they were terrible. You need to look at their stats over a whole season to know the truth. Simulation is the same. One run is just one game. To see the whole season, we use replications. Go to the simulation menu and select Options. Enter 30 in the replications field. Uncheck Show Animation. You don't need to watch it 30 times. When you click Simulate, the model will run 30 times, changing the random seed each time. This shows you the full range of what could happen: the good days, the bad days, and the average days. This output is powerful. Using Smart Stats, you can see the mean, the minimum, and the maximum performance across all 30 shifts. You can even see the 99% confidence interval, telling you where the average population performance will fall 99% of the time. This turns guesswork into factual information for decision-making. Ready to see the big picture? Open the model titled Replications and Output now. Follow the instructions and answer the questions to complete this training. Thanks for watching this training video on variability. If you have questions, start by contacting support at ProcessModel.com. When you email ProcessModel, it is best to send your model along with an explanation of what you want to happen. Usually, within a few minutes, we can diagnose and suggest a solution by return email. As needed, we will recommend a phone call or an online meeting to assist you better. We'll talk with you soon.